using the equation, solving the equation, and we show you what to do with linear algebra, etc., right? And then at the end, we'll be able to use all this, what we teach, to show you that the basic or the fundamental knowledge about neural network. And so, you will not be learning AI without understanding the basic concept. Most times, engineers, the problem with engineers is this. They just use tools without understanding the basic, right? And then the problem is that once you go to industry, sometimes your supervisor, your boss, will ask you to solve some difficult problem. And then usually the problems they give you, it can be solved from an existing program or software or hardware. And they don't need you. Do you know what I'm saying? If you are a more advanced engineer, if you say, let's say you go to industry one day, you want to become an engineer, you want to become a good engineer that you can make money just like TSMC engineer, and you want to be able to promote it to a higher manager or higher level. What's the difference between a good engineer and an ordinary engineer? The ordinary engineer just does the work using all the existing programs. You know what I'm saying? But when a new problem comes, a new challenge comes, what if the existing programs cannot be used? You need to find new ways. You need to find new solutions. Then you need to be able to do something that is not there. And you need to go back to the fundamentals, go back to the basics, right? And in order to create something new. Okay? So that's why, in my experience, when I teach my students, always to go back to basics. Then I ask them to do or create something new that is not existing in the current system or in the current hardware or software solution. And that's what we call innovation. Innovation. Always remember that innovation comes back to the basic stuff. Now, even for let's say even for sports or even for entertainment, this is still the same rule, same principle. Say if you are a good athlete, if you're a good, no matter you play basketball or you play what kind of sports, the coach will always ask you to do fundamentals first, right? Soccer game also, right? Fundamental, right? You need to do, I don't know how to say English. If you're a soccer player, at least you need to do 弹球, right? You need to, for example, a hockey player, you need to know how to dribbling, right? 打篮球的话，你基本功是什么？运球嘛 ，right? Dribbling 运球。那你踢足球的话，基本功是什么？弹球嘛，对不对 ？Okay, so always go back to basic. And if you are entertainment, if you are a singer, at least you have to have good training on your voices, right? So all the same, all the same. So that's what I'm saying. Always go back to basics. So then you understand the principle, then you can do more advanced stuff afterwards. Okay. All right. So let's show you. Okay. So now this is the handwriting, and we are able to just use the basic without more detail. I mean, we're using the basic to create this program. And here we are not using, we're not using any high-end library or function. We're not using any high-end library function. But today, we need to show you more about some libraries that are very useful and powerful. Okay? Because even though this is good, that it starts from basic. Everything here is basic, right? When we go back to basic. However, just like when we write more advanced program, we will create hierarchical structure. And then you can build basic as library, right? And then you build on top of the library, right? And you have multiple framework going upward to do big project. 我的意思就是说，我们现在教的这个是 fundamental， 我们的确在这个城市里，我们了解今天刚刚复习的那个基本的最简单的那个 structure 之后，我们就用 Python 的程式，没有叫任何的 library， 我们就可以做刚才这样的动作，而且这个跑的速度很快因为你越基本的东西跑得越快。但是这个东西，当你在建构很复杂的东西的时候，那我们就会需要把这些基本的东西变成一层一层的结构。那这些底层的结构通常就是 library，library。然后你到时候你就不要再去写底层的，而是直接呼叫这些 library，right？ 对不对？所以为了这个那我们知道大的公司像 Meta 他们就开发了 PyTorch 那像 Google 他们就开发了那个叫什么Google 那个叫什么？我又忘了它名字TensorFlow Google 就开发了 TensorFlow， 还有那个Keras 之类的，都是 library 的东西。那有了 library 的好处就是什么？你可以建构更大、更复杂的系统，然后你不用每个都写很多很复杂、细微的程式。但是写程式的一个原理就是你会越来越高阶，那你可以 create library。所以呢，我们就今天就要来看一下，我们如果用 PyTorch 来做这些程式的时候，它大概的一个概念是怎么样 ？So I was trying to explain that as I said, when we develop a big code, a big software project, then we can utilize library. The library is built up fundamental, they build up from scratch. But once you build up these layers, these library layers, and all you need to do is just call them and utilize them. And then you can save your time, save your work to write up even higher and bigger programs, right? So I hope that through this you can learn something to do by yourself, not just use ChatGPT. You know what I'm saying? Because everybody can use ChatGPT, right? So what's the difference? What's the difference? The best thing is that you can write your own ChatGPT, then you become a valuable engineer. You know what I'm saying? Okay? So every time, if I go back to my laboratory, my lab is 5th floor here. If I see my student not really doing his work, but playing games, a lot of you play games, right? Don't tell me you don't play games, right? Okay? So if I see my student playing games, what should I do? Smack him? Right? No, I will not do that. I will just say, hey, if you have time to play games, why don't you write your own software to make a game for other people to play? Right? Right? That would be more worthwhile, right? When I worked in the United States, 当我在美国工作的时候，one time, we visited a professor, the professor from Purdue University, which is a very good university. That professor also from Taiwan. So we visited his home. Okay? And in his home, he has a 10-year-old child, 10-year-old boy. This 10-year-old boy is a genius. Okay? 他有一个10岁的小孩，这10岁小孩是天才儿童。So I went to his home, and then we parents, chatting and singing together, having fun on the family room. 就是大人都在那个客厅，大家在聊天在玩。And I'm interested and curious to see this child, okay? Prodigy child, a genius child. So I went down to the basement because the kids are playing in the basement. 所以我就到地下室，因为小孩大人都在楼上聊天，小孩在地下室在玩。So I went down to the basement and then saw those games. The kids are playing, okay? But when I entered the room of the basement, 当我进入 basement 的门的时候 I saw a blackboard like this. I saw a blackboard, 海报一样的 blackboard like this. And on top of the blackboard, okay, calculus equations. Alright? What? Calculus equation. His father is a Purdue University professor, right? Teaching his son, okay, 10-year-old son, calculus. Right? That's good. That's a genius kid, right? 10岁就在学微积分，他爸爸来教他微积分 10-year-old kid, right? And then I saw these kids playing. 我就看到那些小孩在玩。And I went over there to see what they're playing. Okay? 那我就赶快去看他们在玩什么。And this kid, David, the professor's son, is playing a computer game. And all the kids are surrounding him. So I'm a little bit disappointed. I said, he's the same kid, just playing games like my students, right? What good is it, right? Just playing games, right? And I was kind of like a little bit disappointed, trying to turn my head and leave. 我这样走的时候 all of a sudden I heard David, this boy, cry out. 这个小孩就突然叫一句话说 something wrong. He said something like, no. He said something like, no. And I switched back and said, what's wrong? What's a no? What's wrong? And I saw this kid, David, toggle his computer screen into a programming mode. So that game was developed by him. He wrote the code, made a game, and played the game, and every kid is watching. Every kid wants to play that game too, you know? So, this is really a genius prodigy. So, see, even a 10-year-old kid can write a program to generate a game, playing. So you guys, certainly, hey, you guys are adults, right? So you should be able to do that too. So I encourage you not just to use ChatGPT only. If you can learn and create your own programs, all right, then it will be more powerful, more useful. And maybe you are a better engineer, all right? And everywhere you go, people will need you. Everywhere you go, people will need you. This is for sure. So over the past years, from my laboratory, I developed all these students who learn how to do programming, how to do system integration, programming, software integrated with hardware, and throughout the years, my lab, we spin off 3 startup companies. 3 startup companies. One is doing 3D printing. The other one, the second one, is doing digital medicine and digital dentistry. The third company is doing AR and VR. You know AR, VR, right? AR and VR stuff. And these students, they all learn. And they all can create. They can do innovation, create their own business, create their own companies. So I encourage you to make yourself more valuable, you know what I'm saying? By learning more, learning from the basics, learning from the fundamental. And if you become stronger in this, I guarantee you that no matter where you go, people will need you. No matter where you go, company will need you. And you get promoted easily. But in essence, all the more important thing is that you need to be proactive. You need to have the desire. Sometimes you need to have the ambition to grow yourself. Okay? And if you don't have that kind of desire, if you're not proactive, then you're just like everybody. You know, you will not make progress. Okay? So I encourage you to do so. That's the real purpose behind the reason I have this class. If you notice, when I teach you this class from the beginning to today, maybe half of what I teach is from the textbook, right? And the other half, where did it come from? I gather more information, and I learn more information, and I put them integrated together, because I feel these will be more powerful and useful for you, right? And if you learn from this class, if you learn where, you actually are empowered to do more. Okay? So this is what I wanted to say at the very end of this class today. That's what I want to make that as a kind of like a conclusion. Okay? Now, so this is the fundamental. Let me show you how we can use PyTorch to do more. Okay? So, this is a program for a linear regression model. Now, the linear regression model is what we taught you review again today, which is actually a simple structure, right? But now if we use Python, we of course can write a program just like for the handwriting. We can write a program to do that. But let's learn how to use PyTorch to do this simple linear regression. Okay? So the basic concept is, first of all, we still import NumPy here, right? And here we import torch. Now torch is PyTorch. Okay? So for using Python and also using Kaggle, it's very simple. When you call a library, you just import torch. That's it. If you write a PC program, sometimes when you want to include a library, it's actually more tedious. But using cloud, using this, using this kind of environment, it's very, very simple, very easy. Just import torch. All right. Now, here we have this problem of linear regression. As I explained today, this is our x input. This is our y input, right? And now we have a linear model. So we said this is a layer, right? Linear model. And this is what we call a layer. It's a single layer. And in this layer, in this case, notice the x, we have three inputs. The x here, we have three inputs, x1, x2, and x3. And then y here, this layer, y, we have two outputs. We have two outputs. And then again, we want to create a w, right? And then the b, right? W is a matrix, and b is a vector, right? And using what we teach, we need to be able to calculate what? Because here we're going to have a loss function, right? A loss function E. And what we want to do is that we need to know what is E, W, and also partial E and partial B, right? Because if we can calculate this two, then we can use them to do W, for example, W, I plus 1 equals WI minus learning rate, partial E, partial W, right? And partial, B, I plus 1 also equals B, I minus learning rate, partial E, partial B, right? Okay, so we turn the linear regression model into a neural network model like this. And we want to use PyTorch to solve this. Okay, to solve this. And don't forget, this problem we can also use what we teach the closed form solution to do it, right? Which is mathematics. Closed form solution can also do it. And now we're using programming to do this. Okay? And here this problem says we have a farm. We have a farmyard. And then we have several factors influencing the products or the produce output, which here, y1 and y2 is the apple. One is apple, the other one is, let me see, one is apple, the other one is orange here, okay? The other one is orange. So the y1, y2 is the output of apple and orange. The output, the value, like how many tons, how many kgs of apple and orange in this year, for example, 2025, all year. How many apples, how many oranges you output, right? But the influencing factors include x1, x2, x3 would be, say, temperature. I think the first one is temperature, right? So the temperature, if it is too cold, no good. If If it's too hot, no good. And then the second one is rainfall, 降雨量, rainfall, right? So how many rains you have this year, right? Rainfall. And then the third factor is humidity, 潮湿度, humidity. So you see, these are all three factors that are influencing the outcome of the production of apple and orange, right? So as a matter of fact, these are two linear regression models, right? So imagine the first one, apple, the APPALE apple equals, we can say, okay, the first one is temperature. So we have a factor, W1 times temperature, plus another factor, W2, which is rainfall times rainfall. This is rainfall. Rainfall. And the third one is W3 times humidity. Humidity. Okay? That's apple. Right? So this equation is a linear regression equation, right? This equation is a linear regression, right? And then the same thing you can use for orange. Same thing. But now, you cannot just say W1 because they are different. So what do? You make it W11, W12, W13, right? And here it becomes W21 times temperature plus W22 times rainfall and plus W23 times humidity, right? And these are two linear regression equations. But we can also make it into a linear model like this. And you have, say, this is y1, y2, right? y1, y2 equals x1, x2, x3, right? And plus b1, b2, b3. Because here I left, this one should be plus b1, and this should be plus b2, something like that, right? And in here, this is w11, w12, w13, and this is w21, w22, and w23, right? So that's a model, that's a layer, that's a linear model. And in writing the program, remember, this one is y equals wx plus b. And in writing the program using the library, we can change it to yt equals x first, x comes first. Because we're using transpose. So this will be x transpose t, wt plus bt, right? So this one can be used for the programming or for the creation of the model. Okay, so let's take a look at this one and we'll see the program. So remember this, okay? Remember this? And we will now show you the program, how to do it. Okay, so here, let's see. Let's see, this is apple volume times. I need to first, okay. 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 So going up. And here we have this equation is the input. Okay. So here the input, you see 73, 67, 43. What is this? That's this. That's the x1, x2, x3, right? x1, x2, x3. The temperature, the rainfall, the humidity. So, okay, so we're saying, okay, for the first year, second year, third year, fourth year, fifth year, every different year. This year, the temperature 73, average temperature 73. And then the rainfall is 67 millimeter, and the humidity is 83. The second year is 91, 88, 64. The third year, 86. So you have all these 5 years inputs. 5 years inputs, right? And the outputs, the targets, is 5670. That's 56 tons of apple and 70 tons of orange, right? 81, 101. This is the fact 5 years results, the outcome. Okay? And then in the beginning, again, we use NumPy array to save the inputs and the outputs. But here, because we're using PyTorch, then we need to convert it. Okay? So we convert it from NumPy to Torch. And then the output, the inputs, and the targets become tensor. Because using PyTorch, we'll be using tensor rather than NumPy array. The reason they created this tensor is because tensor can be multiple dimensions. When we say array, usually it's one-dimensional array, right? And then matrix is usually two-dimensional array, right? And then the tensor is 3 or 4 or 5 dimensions of array. So tensor is more, right? So we can convert from NumPy into tensor. And then again, we can see this is a tensor, this is also a tensor. Okay? And then tensor, this one, because we can see 2 brackets. That means we have 2-dimensional array. If it is 3 brackets, then we have 3-dimensional tensor. Alright? Okay? So this is the use of PyTorch to convert it from NumPy to tensor. Now again, we need to initialize the W and B. So here we have W, right? This is W11, W12, W13. This is W. And also have B. But we have to do initialization, right? Because we're using optimization, right? For optimization, you have to have initial value, right? Initial. So we use this random number. You can call torch.random number to generate the random, statistically random number. So you see here, normally when you use this Rn and Dn function, it will create a number between 0 and 1. Okay, random one, between 0 and 1. So we have all these, no, sorry, random number is not, but this is actually can generate more random, more than 0 and 1. Actually, you see -1 here, -2 here, okay? And important thing here is that it requires gradient equals to true, which means this tensor variable, we can compute the gradient. So this is, usually when they assign it, it will give you this property. And this property says you can do gradient calculation backward, okay? All right, so now we notice that we are creating this W and B initially by random generation. And then X equals W transpose plus B. It says here, the comment says X here. X equals W transpose plus B. Okay? So here X is actually our Y. Okay? We should say Y. Because this is the model. So the input usually using X. Okay? So X into the model. So here, actually, this one is not correct. We should say, we should make a correction here. This one is not true. Let's take out this. So we should say Y, right? Y dot T transpose equals X dot T times W transpose plus BT, okay? So that's this equation. That's this equation. Okay? XT times WT and plus BT. Now in PyTorch, when you are doing matrix or tensor multiplication, the multiplication sign is this X sign. This means two tensor or two matrices are multiplied together by this, okay? By this sign, all right? And then so we can see that we are creating the model here. And then here the X is the input. So in the model here becomes the input, right? This is input. And then we have this. And here, notice the X is actually already horizontal vector here. In PyTorch, normally we assume the X and B, we assume they are horizontal vector. But in mathematics, usually they are vertical, right? Vertical. So that's why we need to do this transpose, right? But in the programming, usually here, the x and b or y, they will be horizontal. Okay? Okay, so now with this, we can see we created a model. This is the Python definition of model, right? We already created this model. This model is done. So we say we can use the model to create to predict predictions. So this one shows that you have model, you have inputs, and you have predictions here. So remember, we're definition inputs here, right? Our inputs here. This is our inputs. Then we use this. We can print the predictions using this model, and this is the outputs. This is the outputs, right? But you notice that the outputs by the current model, there are huge difference between here and here, right? So see this. 因为我们刚才的 WB, because the W and B, they are generated randomly initially, right? So now you are using this model. This model is no good. This model is not accurate, right? And so using this model, the outcome is this, the prediction. 64 minus 44. Oh, there are big time error in comparison with the true value, right? This is the true value. True outcome 56, 70, 81, 101, 119, 133. These are true values, right? But then the prediction from the current model is big time error. They are incorrect. They are big time incorrect. Okay? Now we need to train model to make it correct. So how do we do the training model here? This one is actually using least square. Okay? Using least square. So remember, the least square is what? The definition. The definition of least square. You remember? Definition of least square is error I equals yi minus yi true value, right? Let's say true value here. This is the true value. But then we have to summation and square. So that will be summation and square, right? This is the square, right? Summation and square. And then we can divide it by the total number, right? We can say the total number is n. Okay? So this will become the definition of the sum of the least squares divided by n, which is in the variance sense. This is like a variance, right? Variance. Okay? So here is the definition. Take a look here. Summation, difference times difference. Because difference equals to prediction minus targets, right? So that's here. Prediction minus targets, right? And then the summation of the square values and divided by the number elements. Divided by the number elements. And now, if we calculate this, you will see the error or this criteria here, right? This is our objective function, right? E or F. This is our objective function, equals this. And now this value is very big. 12,529, okay? 12,529. It's a big number, which means right now, the error is big. So we want to, because this is the beginning, the value is here. This error here is big. All we want to do is go down to have optimization, right? We want to drive this curve down. And by iteration. So now we will do the loss function. Here we define this. This is the what we call minimum least square sense, right? So we will put them into a loss function. Okay? So we define MSE as T input T1, T2, and then this return the definition of the least square, right? The minimum square, right? So this is the definition of loss function. Then we can use this loss function to do calculation. This will be the same as this one because we're using this as a function, right? So that's the same. Now the key here comes. The advantage of of using the library is they already done everything for you. So all you need to do is just call this backward. Right? Because we're not computing the complex equations anymore, right? Remember I showed you the equations. Please remember memorize those things because I might give you a test. That, okay? But here, you don't have to remember anything, just call this backward, right? So it's simple. Those are the basics you need to know. But here, when it is in PyTorch, just one command. Backward. It's done. It's already doing everything for you. It's doing all the back propagation, the chain rule propagation. Everything is already done in here. It's done already. And you don't have to do anything. So simple. And then here we see, now we have this result. So if I lost dot backward, I calculated gradient, and I want to show W. Here's the W. Here's the W. So I can show W and W gradient. So this is the gradient, this is the W, this is the gradient. So W is already what we generated from the random number. And here is partial E over partial W, remember? And then we use that to calculate W1 equals W0 minus learning rate times partial E over partial W, right? And then you get this result. You get this result. So it's already done for you. And this command already done for you. And even if you have multiple layers, it will also do it automatically for you. Okay? So this also shows you can zero the gradient. Why do you want to zero the gradient? Why do you want to zero this gradient? It's because when we are using this equation here, every time when we calculate the new WI, right, then we will calculate this again, right? See, this equation is in iteration. So every time you calculate this equation again, you need to calculate this one more time, right? And so you need to get rid of the previous one. So the previous one calculated, you want to get rid of it, and then set it as 0, and then do it again, calculate it again, and then put into this equation to update the WI plus 1. You know what I'm saying? Okay? So that's why you can use this command to set it as 0. Okay? Okay, so probably that's all you need to do. Let's see this iteration. This is the training. So here it says train for 100 epochs. Epochs means 100 iterations here. So for I in range 100, that means we're doing 100 iterations. Then we're using this prediction equals model, loss, this is the loss function, and we're doing loss backward. And here we're calculating using these equations. Right? And this one, notice the learning rate is 10 to the power of minus 5. A very small number. Here. You can use W dot grade. W dot grade is this, right? W dot grade is this. B dot grade is this, right? And you can do W equals W minus this. B equals B minus this, right? And then set it back to 0 again, don't forget. W and B need to set it back to 0. So you can keep updating this, okay? And so this equation, basically, you do 100 times, right? And then we will see the results. We can see the results. So let me do it. Let's go back here. From the beginning, we need to do it again. So here is 1, 2, let's do 3. It's already done. And here, start target. And then input. Okay, so it's done. Do this. Randomization. And define. Let's do it again. Okay, sequence done by now. And actually, once you write a complete program, you can just run it completely. Not like I'm doing click by click here. You can do the complete program here. So we're just going through see the results, each of them, right? This is like integrated mode, iterative mode. You can see this interpreted mode. You can do this, you can show all the progress. You can show the progress, right? And here, also we do this again, we see the result the same. And we define the loss function. We go back, loss backward. And here, we can print the result showing the W and the W red, the same. And here also, this is just showing the setting of 0. And here, it's the same. That now the model, the training model is not good, right? The training model is not good. So we want to do training now. So now we'll see the training from step 1 to 100, okay? So let's say this is the definition, this is running the results, okay? And then let's see the result here. We should have same. Okay, so now here is not same. Here is 155. So through 100 iterations, we reduce the objective function. 我们经过100次的迭代 reduce the objective function E here. We're going to go down here. Now remember in the beginning, it's a big number. 好像13000多。然后我们现在100次以后呢，得到多少 ？So in the beginning, let's go back to see in the beginning before iteration or before training. Before training. Here, this is 12,974. It's a big number. It's a big error, right? Big E over there. But after 100 iterations, after the training, let's check the number again. After the training here, it's 155. We reduce it to 155. And let's see, the prediction is this. And now the prediction is more accurate because the model we created now, and then with the prediction, after 100 iterations, we now have 6073. And this is 5670. Okay, still a little bit difference here. Through 100 iterations, let's make the comparison. You see, this one is 6073, 8793. But the true value is 5670. So still a little bit deviation, right? A little bit. 6070 is 56, 57, and also 8196. Oh, this one 81 is pretty close. This is 87. 101. 101, this is 199, 119, 137, 133. So they are kind of close, but this one is big error. 42 and only 22. 98, 103. So still deviations because we're only doing 100 iterations, right? So let's increase the iteration. Let's see how that goes. So now if we go back to make a change here, we already have done 100 iterations. Now if we change it to 500, so we have more iterations. Actually we have 600 iterations because we already done 100. So we're adding more. So 100 iterations may be driving us from here to here. Okay? And then now let's get more iterations finally, so we can reduce the error more. So now remember, in the beginning, before iteration is 12,000. After iteration, before iteration is 12,000, right? The number is like 13,000, okay? And then after 100 iteration, it's 155, right? Now let's do more. So we do so we want to see 155 continue to drop, continue to decrease, because we're going to do this again. But this time we'll try 500 iterations. So let's do that. Okay, done. And now let's print it. Let's do the print loss again. See, 18. From 155 now reduced to 18. So 13,000 to 155 now to only 18. So the error is already reduced very, very much. Reduction. And now let's compare it again. So if here, you see this is the, after 100 iterations, we see the difference here, still a little bit big, like this 42, 22 is still a very big difference, right? But what about, let's do this again. Let's see the prediction, and let's do this. Okay, now you see, it's much close, right? 57 to 56, 70 to 70, 83 to 81, 96 to 101. It's a little bit difference here. 155, 150, 190, 11.5, this is 11.9, it's 140, it's 133. Now it used to be 40 here, now become 21, 22, 37, 39, 37, 103, 104, and 119, and 110. So already very close. Now if you can do more iterations, certainly you should still get more closer results. And now, the conclusion. If I give you this as your final exam, you don't have a computer, you cannot do this, right? But remember, I gave you the formula, right? You can get the results, right? Right? And then the thing is this. See, we are typing the programs using many iterations. And this is only a simple model, so we get the iterations and then we get this result. And even after 600 iterations, it's still not that good. It still has the discrepancies. It's still problems, right? But if I use my mathematical calculation, I will get the true optimized value. It will be even close to this final results. You know, through the equation that I showed you. Remember the equation? You said, what equation? Let me give you that equation one more time. Remember we have linear regression model like this, right? And remember we said y equals a inverse ATY. Sorry, x, this is x. Right? Remember this? That's only one line, right? That's only one line. Now, see, if I can do this, I will put this as x1, x2, and this will be y1 and y2. Now, see, this one actually becomes x, a bigger model. This is the x matrix, right? That's x matrix. Still equals ATA and inverse AT and y, right? So through this equation, I actually can get the true minimum value. The result will be even better than this, just by this equation. That's the basic idea of the mathematics, right? And see, the AI program is good. You can do this. But it still takes a lot of iterations. And through 600 iterations, you get a number that's kind of close, but not that close. Not that close. And then the equation of mathematics can improve that result dramatically. So what does it say to us? What does it say to us? It says, if you have ways to improve this by having more intuition or direct results from mathematics, you may be able to use this to improve the results. So that means current modeling of AI still has a lot of improvement can be done. There's a lot of improvement can be done. Because using gradient, decent gradient search is very slow. It's really not efficient. Do you see that? It takes a long time to do this, right? 600 iterations. And now we have a bigger model, we have more parameters, right? We have billions of parameters. That's why it takes 3 months. That's why it takes 3 months to get it done. And do you know 3 months of using GPUs and supercomputers to create a model? It takes so much electricity. It spends so much money to create a model. So, question, is there any easier way to help this, to improve this? there's a good story. Do you remember? There's a China company, DeepSeek, right? 1 year ago, they announced they have a new model, right? And that is much smaller, much saving more time, much faster, and using less memory or whatever, right? And then you don't have to pay that much as you pay to ChatGPT, right? Do you know what they did? Fundamentally change? What they did, the most important improvement they did is actually very simple. Can you make a guess through this? Can you understand? What's the problem? What did they do to make this change?
The outputs of the available models and produce the recursive learning on the models that are already available. So they didn't have to retrain it. They didn't use that much more.
Yeah. So the people criticize they're stealing. They kind of like use the existing model, or like a pre-trained model. That's number one. But then the second thing, the most important improvement, the easiest way is this. You know, we are using, let's see. You see the difference, major difference is here. When we use the inputs, we're using flow 32, we're using a target, we're using flow 32. And then we actually also use W here. And then the W beat the D4 also flow 32, or sometimes 64, right? But then they show that you don't really need that kind of a high floating number, 32 or 64, to do W and B. Remember we said we have billions of parameters, or even trillions of parameters, right? And if you represent those numbers in W and B using this kind of a float 32, or even 64, you know float 32 is how many bytes? Huh? 4 bytes, right? Because 8 bytes, 8 bits is a byte, right? Yeah, 8 bit is a byte, right? So this is about sensor 4832, right? So you are actually using 4 bytes, right? Now, when they say instead of using 4 bytes, what about if we just using 2 bytes? We don't need to use that kind of a long sequence of digits to represent W and B. They just save a lot of memory, save a lot of time, save a lot of computation. Okay? And that's a very simple idea only. Very simple idea. And then they can reduce the model. Okay? Saving time, saving memory, saving electricity, everything. So I'm using this example to just tell you that if you know from fundamental, you know from the basics idea, there are still ways to improve the result, or the accuracy, or the speed. Right? So if you learn that, you should be able to do that. If you don't, as I say, depends on what kind of engineer you want to be. Right? If you just want to use ChatGPT, then you are no different than other people. But if you learn more, you care more about the fundamentals or the basics, then you can do more. Okay? Okay, so one more thing before we end the class. I want to show you that if instead of using a simple model to do this, and remember this one creates about 85% accuracy. This one produces about 85% accuracy. Let me see where it says the accuracy here, somewhere. Okay, here, 84% accuracy. Okay, 84% accuracy. Now we have multiple layers, more advanced multiple layers, and we can increase the accuracy to do this. So let me find the program. here, we can even have a ChatGPT model here. This is all for him, okay? Now, build a simple ChatGPT here. We can do that too, okay? And let's say, let me see. Okay, here, this is another program. Let me see. Okay, not this guy. Not this guy. Let's see. Nope, not this. Okay, maybe that's it. Okay, so here we are doing this handwriting digits again. But this one, we are using more layers. And you can see we drive this cross-sectional function down to almost kind of like 0. So the accuracy is improved much better. And how do we do that? We are simply using the PyTorch function to create more layers. This one, well actually this one is not multiple layers here, let me see. This one actually, 3 layers only, okay? So, here you see, we are using, this is initialization, just like the W and B initialization. And then matrix 1 equals linear first, and then second linear, third linear, and then the value function. So actually this is still a simple, not so complicated model. Only 3 layers. We only have 2 layers there, but this is 3 layers. And so this one is really not that much of a difference, but we can still improve the accuracy and create, this loss function, drive the loss function down to create this, again, 9, all this different values. So that here, I think we have different programs here, another program to do this. Because this is like a long time ago, I forgot. So this is like 7 and 5. It's incorrect. So not a good model, actually. Then if we have another case, let me see. Let's go back to see another one, maybe. Okay, let's see. Change a different name rather than this. Okay, so this is a GAN, this is from website. We can see it actually has more, this is a different program, but this one is to show you a GAN model. No, let's not do that. Let me see. Somewhere I did it a long time ago. Probably lost it somewhere. Okay, anyway, just like I show you, with more layers, we should be able to increase the accuracy. Okay, like this one. Okay, so this is multiple layer. Layer 1, hidden layer 2, and outer layer, and then the forward also here, relevant function. This one. Somehow I didn't do it correctly, but this is probably the different case. But anyway, the idea is that if we can have more network like this, and then you have multiple layers, increase the multiple layers, you have more W and B, then eventually you will have a higher order, better complex model to do prediction. Then you can increase the accuracy. Like I promised you, that should have more accuracy. Okay, so today I think this is kind of like wraps up the discussion. Sorry, the last case I did not prepare it well, but the idea is that you can increase the level of complexity to do a better, show a better result. But always, I want to come back to tell you, to ask you, because this is kind of like the introduction course. So I'm not asking you to do more, but I just ask you to remember the basic idea behind all this. All right? And then later on, when you go to another artificial intelligence course, you'll learn more. You probably learn more complex models, like I showed, the GM model, the auto regression, and the UNet, many different things. These days, we even have more complex models to learn. And then you'll be able to do many more things, okay? But always remember, all these neural networks come back to this basic idea, this basic model, okay? So that's probably the end of my class that I want to let you know. But if you guys are interested, you are still welcome later. For example, I told you that I have my students on my lab are doing also similar, many applications after this. So if you're interested, you're also welcome. If you have any question, even after class, we can, if you have time, we can also have more discussions. Okay, so that's about it. Next week, we're gonna have the exam, right? And it's gonna be 2 hours exam. And I will prepare more problem sets for you. So the total score will be more than 100. Probably it will be 120 or even 150 or 130, right? So you just write as much as you can, okay? The more you learn, the more is yours, okay? Alright? Because I know the first midterm you're not doing good, right? So let's say if the first midterm is only 30, right? Now if you can do 150, right? I put those 50 back to the first one, alright? So then we don't have to have the second midterm. But the final, I probably give you more than 7 or 8 problem sets, alright? And then the more you earn, the more grade you have. Is that clear? Okay? And also don't forget what I reminded you last week about problem sets I might give to you. And maybe even including today, I show you the basic stuff. I might give you some problem regarding this basic concept, or basic idea. Okay? Okay? And then just as last time, don't use your computer, notebook, iPad, or even your cell phone. Okay? And use only the calculator. Okay? And my teaching assistants will still look for you. If you are not, you might get flunked automatically if you're not careful. Okay? Okay? So that's it. We'll see you next time. Okay? Okay?